Hello and welcome back to another VMK in the game development series. In this VMK, I'll be showing you how to implement the visibility and invisibility of objects. So with this ability, you'll be able to turn objects off so that you don't need to render them if you don't want to render them. So for instance, if you had a character on the screen and he's running around and then you shoot him and he goes and dies, well, you still have to go and render him if he's laying on the ground. If you don't want a bunch of dead bodies piling up on your screen, well then you have to be able to remove them. So to be able to remove them, this ability will allow you to make them invisible, and then OpenGL doesn't have to worry about having to render them on the screen. So that's what we're going to go and implement now. You'll remember previously we went into the material class and removed the ability here to set the object to be invisible. We're going to take that parameter and we need to move it into the node class. So inside here, inside the node.h file, at the very bottom, we're going to add a member. Now I notice that the name for the nodes is currently public, but I don't want the name to be public so that people can change it any time they want. So what I'm going to do is take this guy and move him down and make him private. By doing that, if I save this and rebuild the project, it shouldn't make any difference. And as you see there, everything's still fine. Now what I'm going to do is inside here add a new parameter, and it's going to be Boolean, and we're going to call it mbVisible. And I'm going to take this parameter, and inside of the constructor, I'm going to assign it to be true. So by default, whatever we create will be visible, which is something that is kind of helpful. We don't want to be creating things that are invisible, because then we might get worried as to why we don't see them. So everything's going to be visible, and for this to work, all we really need to do is make one change. And the change itself will happen inside of the node transform. So inside node transfer under render OpenGL, whenever we're rendering, we're going to be going through the tree structure to determine how to translate the current location, how to render it, and then so on and so forth. Well, if something is invisible, we don't want to render it. And the original idea that I had was I'll put this invisibility ability inside of the material class. But doing that is kind of a hassle because, for instance, imagine having a character that's made up of a chest, 2 legs, 2 arms, and a head. And each of these can move independently of the other. So, you know, the player can turn his head left and right, he can swing his arms, and so on and so forth. Well, if we had the visibility parameter inside the material, then that means each of those pieces of the animated body are able to be turned on and off. Well, this is great. However, if I wanted to, say, make the entire body invisible, I would then need to go inside every single piece and make that parameter invisible or set it to be false. I don't want to do that. That's a lot of work. So by moving that parameter inside of the node class, it gets inherited into the node transform, and then inside node transform, what we do is inside this if statement, we also check to see if it's visible. So if it's visible and there is something nested underneath, we'll go and render. If it's not visible, we skip this entirely and continue on through. So in other words, everything that's nested underneath this transform, if it's set to be visible, it will render. If it's nested and this parameter is false, then everything underneath will become invisible, and we don't have to worry about it. We only have one parameter that controls everything inside of the tree. So if we set the visibility right at the very root and set that guy to false, then everything in the scene will become invisible, which is very powerful because one parameter is controlling everything. And so if you structure everything in your scene graph to be nested accordingly, properly, then you can give yourself a lot of control in terms of what you're able to make visible and invisible and group items appropriately. So that's all we need to do. Now let me go and demonstrate how this works. To do that, let's go inside of the scene, and inside initialize, I'm just going to create 3 boxes on the screen, and I'm going to nest a couple of them so that you can see how this nested visibility actually does work. We have our texture, we have a texture transform, we have a material, we have some geometry here, geometry for box. Okay, we'll go and use this guy in a second. And actually, I'm going to rename this guy just to be a little bit more intuitive, P-box. And inside the nodes, we have the geometry for the ground, and then we have this plane that we're just playing around with in the previous video. So down here, I'm going to go and add the code for our 3 boxes. Now, I'm not going to go into details as to how this code works. You've seen this code many times now. I should be able to just scroll through it, show you what numbers I'm using, and you should have a pretty good understanding of what I'm trying to render on the screen. So here we go. We have a transform. Actually, you know what I'm going to do? I'm going to go inside of a PaintShop Pro and give you a visual representation of what I just constructed there inside of the scene. In the scene, we have 0, 0. This is where you're going to start off. This is a top view only. So here, this is the Z direction for the negative, and this is Z direction positive. So this location here is 0, 0, 0. And in our scene, we have our plane, which is sort of in front of our faces like so. And what I'm going to do with the 3 boxes is I create one transform which moves the location of the transformation to be -2 units, or actually +2 units, so it's behind us. And I'm going to label this transform location to be root box. Then I'm going to create another transformation which is going to move with respect to this location, and it's going to move 1 unit to the right and then 1 unit back. And here I'm going to render our first box. Then what I'm going to do is take this location again, and I'm going to move 1 unit to the left here, and then I'm going to move up 0.5 units. So there's going to be a hovering box located right here. And I'm going to name this transform to be nested. And then I'm going to place the third box with respect to this one. So I'm going to start here. I'm going to move 1 unit to the left, and then I'm going to move 1 unit down, forward in the Z direction. And then I'm going to place a box here that's located half a unit up with respect to this one, which will mean it's exactly 1 unit up with respect to the ground. So this box is going to be hovering higher than this box. This box is going to be hovering about half above the ground, and then this box is going to be sitting on the ground. And then this last box is going to be nested under a transform that's called last. So we have root box, which has all of them. We have nested, which just has these 2, and then we have last, which just contains this last box. So let's go take a look at the code. And okay, here it is here. So we have our first transformation node, call it root box, moved 2 units into Z. Then we have another transformation node that's nested underneath this first one, and it's 1 unit to the right and 1 unit down further. And then we place our first node shape, which is that box, underneath that transformation. And we assign the same texture that we've been using up till now. Then we have another transform node here, which I call nested 1, and I'm moving it left 1 and up half a unit, and we place a box there. And then finally we have the third transform, which I call last. It's -1 plus 0.5 and then 1 in the Z direction, and then that's where our last box goes. Okay, so let's go and run this. Actually, what I'm going to do is inside update. I'm going to remove that code to remove the texture transform manipulation that we were doing before. Okay, so when we run it and we turn around, we should see 3 boxes. There's one box on the ground, one box a little bit higher up, and then the third box, which is higher up still. Okay, so now that we have that in place, let's go and see how we can play around with the visibility. Inside the update here, I've gotten the following code. I go and take a look for the location of the node that's called last. So that should be, if I go back into initialize, it's the last box. Where is it here? Last. It's the last box that is rendered inside of this miniature tree. So if I go back into here, I'm referring to this box here. And he will, I go and look for him. If I find him, then I do a comparison here in time. So what I do is initially I get a time, and then I get the time again next time through. If this difference here is greater than 1,000, so in other words 1 second, then I toggle the visibility of this specific node. And then I go and set the time again. So this is just like a little time delay. And every second, basically, I'm changing the visibility of the box that's called last. Or I guess I should say the box that's stored underneath the node that is named last. So let's go and run this and take a look to see what happens. If I turn around now, you'll notice that top box is blinking. And during the encoding of this video, I hope you can see that box blinking. I'm not sure if you will. If you don't, you'll have to just build this code yourself and check it out. So that last box is blinking. Well, now what I can do is go in here and say, instead of that last box of visibility, I want to change the next box up, which is, I think I called it nested 1. Let's build this. Now, I'm changing the visibility of only one node called nested 1, but you'll notice it's actually changing the visibility of 2 boxes. And this is because these 2 boxes are nested underneath that same transformation. And if I go back into here, you'll remember the way that this tree is organized. Let me draw this a little bit more clearly here. I have a transformation which is called root box, and then underneath him I have another transformation which is called nested 1. This should be nested 1. And then underneath him I have another transformation, and it's called last. So I basically have this sort of structure. And if I choose this guy here, which has our box, the third box, call in number 3, this is number 2, and this is 1. Each of these transformations have their own box nested underneath them. Box 2, and this guy has box 1. So if I select this transformation node, it's going to turn this box on and off. If I choose this one, it's going to turn this box and everything underneath it off and on appropriately. So that's why you're seeing these 2 boxes disappear. Now if I choose the root, well, then I can make all 3 boxes disappear. And I can just demonstrate that by going root box. And there you go. Pretty simple. You'll notice now that all 3 boxes are blinking on the screen with a 1 second time delay. So there you go. making things visible and invisible, very easy to do once you've placed that visibility marker inside of the node class. If we had it inside of the material class, which is associated with each object, if we wanted to replicate the exact same thing, making all the boxes invisible, we would need to go and find each of the 3 boxes that are located underneath each other and turn their visibility on and off. But that would have been a lot more work, so instead of doing that, we moved the visibility to the node, and then by just changing the visibility of a specific node, you make everything underneath it invisible. Okay, so I hope you can have fun making things invisible and visible now.